Hash join can be used for equijoins and natural joins. It happens in two phases: partitioning and probing. In the partitioning phase, which is the first phase, which is also sometimes called building phase, we use a hash function to partition both of the relations. The hash function partitions the relations based on join attributes. The idea is to partition the tuples in both of the relations using the same hash function into sets that have the same hash value on the join attributes. When we have the partitions, we can read in each partition of the first relation, which preferably is the smaller relation, and scan just the corresponding partition of the other relation for matches. This happens in the second phase. For the second phase, called probing or matching phase, we need another hash function so that we can build an in-memory hash table for the partitions of the first table for matching within a partition. We need memory to build and hold this hash table, which increases the memory needs to be more than only the loaded partition from the first relation. Using this method, if we have enough memory available, once we load a partition from R and match a corresponding partition from S for it, we do not have to consider those partitions of R and S again. There are different versions of implementation for hash join, but here, let's take a look at one version of a simple applicable pseudocode. In the partitioning phase, using the same hash function, we partition each of the relations R and S into K partitions. In the second phase, we load each of K partitions from relation R and build in the in-memory hash table using the hash function H2 for that partition. Then, using the same hash function, H2, we probe the corresponding partition from S for matching tuples and output the join results. At the end of each iteration, we clear the hash table for the partition to prepare for the next iteration. The cost analysis. Similar to previous algorithms, assume we have m pages in relation R, each page containing PR tuples, and n pages in relation S, each page with PS tuples. In the first phase of this algorithm, which is the partitioning, we have to scan both relations R and S only once, and we have to write them out once. The cost, therefore, will be sum of the size of both relations times 2, which is 2 times m plus n. In the probing phase, if there are no partition overflows and memory is enough so that we can fit our partitions into the memory, we only need to scan each partition once. This will be again the sum of size of relations, which is m plus n. The total cost is therefore 3 times m plus n. Applying this analysis to our example relations, students and enrolled. If R, which is the students table, has 1,000 pages and 100 tuples per page, and S, which is the enrolled table, has 500 pages, the total cost will be 3 times 1,000 plus 500, which is 4,500.